So welcome to another session of Everyday Mathematics. If you've not subscribed to our channel, we do really encourage you to subscribe to our channel. Here at Everyday Mathematics, what we do is we go about and around and look for interesting problems. We try and solve them, and then we do share our versions of the solution with you. So today we continue with MIT Integration B qualifying exams 2010 rather, and our focus will be on problem 21, which is the definite integral from x equals to 0 to x tending to infinity of 1 over the square root of 1 plus e to the power x plus e to the power 2x. So I hope you stay locked as you just watch how we try and solve this. So our problem being the definite integral from x equals 0 to x tending to infinity, or 1 over square root of 1 plus e to the power x plus e to the power 2x. This is our problem. The first thing I'd do is I would divide both the numerator and denominator by e to the power x. So 0, infinity, divide by e to the power x. Here, when I divide by e to the power x and take everything inside the square root sign, so we have e to the power, plus e to the power x divided by e to the power 2x plus e to the power 2x divided by e to the power 2x dx. So this becomes 0 e to the power negative x over square root e to the power negative 2x plus e to the power negative x plus 1, right? So that we can go ahead and express the denominator as an interesting expression. This is the same as e to the power x plus, let's elongate that, a half squared plus 3 over 4. Because a half squared will be a quarter, and looking at 1 here, a quarter will be 3 over 4 less than 1 dx. So that's where we get. Let's continue. So our integral now becomes the integral from x equals 0 to infinity of e to the power x over the square root of e to the power x plus a half squared plus 3 over 4. And so we have to express this part so that the constant is 3 over 4, so that we can factor that constant away. And then if this is tan squared theta plus 1, and so the quickest substitution would be let e to the power x plus a half be equated to square root of 3 over 2, so that when you square it, it becomes 3/4 tangent theta. So negative e to the power x dx d theta is equals to square root of 3 over 2 sec squared theta. And so negative e the power x is equals to over 2 sec squared theta d theta. And so we can substitute for e to the power negative x dx with negative root 3 over 2 sec theta d theta. Let's look at the limits when x, let's say when x equals to 0, that means that e to the power 0 plus a half equals to root 3 over 2 tan theta. It means that this tends to 1, and so we have square root of 3, and so we have root 3 equals to tan theta, and theta is equals to arctangent of root 3. X equals to 0, and x equals to infinity, or tends to infinity, we have 0, because essentially e to the power infinity tends to 0, plus a half equals to root 3 over 2 tan theta. And so half these two cancels, we have a tangent of 1 over root 3 equals to theta. So this is arctangent 1 over root 3. Okay. So we have our limit x 0 theta arctangent of root 3 tending to infinity is arctangent of 1 over root 3. And so we can draw something like that. And for this case, we have root 3 over 1. This becomes 3 squared plus 1 squared is equals to 4, and root 2 so is 2. And therefore, that angle theta there is equals to pi over 3. Okay, because sine theta equals to a half means theta is pi over 3. And then when you have a scenario like we have 1, we have 3, and then here we still have 2, so this angle here becomes theta is equals to pi over 6. Okay, so our integral 0 tending to infinity e to the power x dx over square root of e to the power x plus a half squared plus 3 over 4. This is the same as lower limit pi over 3 pi over 6 negative sec squared d theta for this part here. And then we have, under the integration signs, we have 3 over 4 tan squared theta plus 3 over 4. And so this is the same as this negative allows us to flip the limits. So we have sec squared theta. And then when we pull 3 over 4 out, we have 3 root 3 over 2 tan square theta plus 1 is the same as sec square theta, then square root, we get sec theta d theta, and so that's squared and that cancel. Okay, and let's keep going. It's important to note that we were supposed to have square root of 3 over 2 here, square root of 3 over 2 here, so that that and that would cancel away. So essentially we are left with the integral from pi over 6 to pi over 3 of sec theta. And we're going to see how to solve that in a minute. Integral is from pi over 6 to pi over 3 sec theta d theta. I'm going to use a nifty trick here on how to solve this. So theta is the same as tan theta plus sec theta, like that, divided by tan theta plus sec theta d theta. So which is the same as pi over 6 power 3 sec theta square theta plus sec theta tan theta over tan theta plus sec theta. We see the numerator is the same as d theta of tan theta plus sec theta over tan theta plus sec theta, and that means that this is the same as the natural logarithm of tan theta plus sec theta with the limits pi over 6, pi over 3. Okay. So we said our integral is natural log sec theta plus tan theta pi over 6 pi over 3, which is the same as natural log of sec pi over 3 plus tangent of pi over 3 minus log of sec pi over 6 plus tangent pi over 6. So this is the same as sec is the same as obviously 1 over cosine. So this is the same as cosine of pi over 3 is a half. So 1 over half is 2. And tangent of pi over 3, as we saw previously, that's the same as a situation where you have root 3, right, minus log second pi over 6. That's the same as 1 over root 3 over 2. So this is 2 over root 3 plus 1 over root 3, which is the tangent of pi over 6. Okay. And so here the common denominator here, so you have 3 over root 3, which is same as root 3. So we have log 2 plus root 3 minus log of root 3, which is equals to natural log of 2 over root 3 plus 1. And that's the much awaited answer. Thank you.